we shall discuss the MCQ questions on spatial function and series solution in this video lecture. So let's see what is the first question. So the first question is Bessel's function of order 0. Bessel's function of order 0 is required, right? So in order to answer this question, you should know what is the Bessel's equation of order n. You should know the expression for that, right? So what is Bessel's equation of order n? So Bessel's equation of order n is nothing but it is given by x square into d2y by dx square plus x into dy by dx plus x square minus n square equal to 0, right? So this is a Bessel's equation of order n, where n must be a non-negative constant, right? When n is a non-constant, non-negative real number. This can be sometimes also written as this equation just by dividing by x square. So you will find another form, that is d2y by dx square plus what we have 1 by x into dy by dx plus divide by x square. So x square by x square is 1 minus n square by x square equal operating on y obviously is equal to 0, right? So these are the two different forms. Why I am telling you so? Because sometimes instead of Bessel's equation of order n as this one, they may give you this expression, right? So you should understand that this is another form of the Bessel's equation, right? So this is for order n. Why? Because of this n term, n square term. So here I wish to obtain a Bessel's equation of order 0, right? So what I have to put? So just put n equal to 0 over here. So say for example, this is our equation number 1. So putting n is equal to 0 in order to get Bessel's equation of order 0 in equation 1. In equation 1 we get, so what we will get? So we will get this as x square into d2y by dx square plus x into dy by dx plus x square. N is 0, right? So x square y is equal to 0. But we don't find this type of option over here, right? So it doesn't mean that the option given are wrong. So sometimes we have to do certain adjustment in order to fit with the given option. So what you will find here, that everywhere obviously d2y by d square means y2 term must be there. So here in 3 different choices I am observing y2, right? So obviously this is discarded completely. This is completely wrong. So we may have the expression either of the form b, c or d. So how to get that? So here you find that the y2 is having coefficient as x. So if suppose I will divide by x, what I shall get? So what I will get? So I will denote d2y by dx square as what? y2, and I am dividing at the same time by x. So here x is left, dividing by x, so x will get cancelled. I will write dy by dx as y1 plus again x will get cancelled, so it's xy is equal to 0. Just look for this option. So this option we find in the, what is the value of integral from -1 to 1 of p0 of x, right? This we want, right? So how do we get this? So here we have 2 different options which will help us to get the value of this p0 of x. So what this says, the first option, method 1. So here we will use just one simple standard results, right? So what it says, that integration of Pn of x from -1 to 1 is nothing but 0 when n is not equal to 0, right? Means when n is taking all the values other than 0, then what is the value of this integral? It's 0. And when n is equal to 0, then the value comes out to be 2, right? So either one can remember this result, or what is the another option? So as we know p0 of x, right? What is p0 of x? It is nothing but the What is P0 of x? It is the Legendre polynomial of order 0. So for this we know various expression for Legendre polynomial of various order P0 of x, P1 of x, P2 of x, like this, right? That you should remember if you want to answer the question based on spatial function. So what is P0 of x? P0 of x is nothing but known to us, that is 1. So we will just put the value of P0 of x over here, so 1, and then integrate this 1 and apply the limit, then also you will find the answer as 2. So what is the correct option? Option number B, right? So sometimes question look very simple, but it is nothing but the easy to, look simple, and it may have the different methods to get the answer. Okay, so as I said, I think the blocks have been shifted here and there. Okay. Now next question. The value of integral from -1 to 1 of Pn square of x dx. This we want. Remember, don't use the earlier result. Earlier result is used only if you will have integration of Pn of x and not the square of that, isn't it? So how to solve this? So here we will make use of the property. So what is the property of Legendre function? So this property is called as the orthogonal property, right? This property is called as orthogonal property of Legendre polynomial. Okay, so this is one of the standard result generally asked in the exam for the derivation if it is a subjective type question, right? But being a objective type question also, this is used, right? So what is this result? So it says that when you have to integrate the product of two Legendre polynomial of various order, say m and n, right, over the limit -1 to 1, so its value is 0 when these two orders are different, and when they are same, then its value is given by 2 upon 2n plus 1. Now, so here I am not finding such type of terms, but I can relate. Pn square. Pn square means when this is possible. So when you will get Pn square. So if m is equal to n, right? If m is equal to n, so both the terms will be same. So this will become what? Pn square of x, right? So this result, which is for m is equal to n, can also be written as integration of -1 to 1 Pn square of x is equal to how much? It is nothing but 2 upon 2n plus 1. Okay, so what is the answer? Answer is option number A. Okay, now let's have the next question. What is our next question? One of the recurrence formulae is, so here various formulas are written, and you have to identify which one of the following is a recurrence formula. Maybe one of them or maybe all of them. So how do we get this, right? How do we get this? So this can be better answer just by recalling the recurrence relation formulae of what? The Bessel's function. So as we know, there are 6 recurrence formulae, right? There are 6 recurrence formulae, and these 6 recurrence formula are, so what is our first recurrence formula? So first recurrence formula is the derivative with respect to x of x raised to n into Jn of x, right? Jn of x is what? It is a Bessel's function of first kind. Bessel's function of first kind of order n, right? So that is equal to what? X raised to n, then Jn minus 1 of x. This is my first recurrence relation. Do we get this here? No. Now, what is the second recurrence relation? So second recurrence relation is, it is nothing but derivative with respect to x of what? X raised to minus n Jn of x is equal to what we have? Minus x raised to minus n Jn plus 1 of x, right? So this we find in the option number C. You can observe option number C, right? So recurrence relation 2 is given in the option number C. Now Let's have the third recurrence relation. What is our third recurrence relation? So third recurrence relation is, it is Jn dash of x, right? Jn dash of x is equal to what we have. This as Jn minus 1 of x minus n by x times Jn of x. This can be written in different form just by shuffling the term here and there, okay? Or sometimes the is also written as x, then Jn dash of x is equal to what we have, minus n Jn of x, right, plus x j n minus 1 of x. So as I told you, just by rearranging the term here and there, you can have a different form for this recurrence relation number 3. Now just see, are you getting this recurrence relation over here? Yes. So answer is no. Why not? Because here what we have? We have Jn minus 1 and Jn dash. But in the recurrence relation 1, what we get? We have Jn plus 1 and Jn dash. So obviously, if it is not here in the recurrence relation 3, so it will be where? It will be in the recurrence relation number 4, right? So answer for this is here, as it mentioned, it is all of this. Option D. Option D means all the three above are the recurrence relation. So let's see what is the recurrence relation number 4. So recurrence relation 4 is, so it is given by, again it is related with the derivative of the Bessel's function. So that is Jn dash of x is equal to what we have, n by x, then Jn of x minus Jn plus 1 of x. So here Jn dash and Jn plus 1 is related, or it is also written sometimes as x Jn dash of x is equal to n Jn of x minus Jn plus 1 of x, right? So this is our what, the fourth recurrence relation, and it is there in the option. You can see here, you can see here this Jn dash of x n by x Jn of x minus Jn plus 1, so which I have written in the this earlier expression, matches with the first option. Okay, now let's have the fifth recurrence relation, right? So as I told you, in all, how many recurrence relation we have? 6 recurrence relation. What is the 6th recurrence relation? So it is 2 times Jn dash of x is equal to, here it relates the three different Bessel's function. So that is Jn minus 1 dash of x minus Jn plus 1 of x. So this is my recurrence relation number 5. And finally we have recurrence relation number 6, which is nothing but Jn minus 1 of x plus Jn plus 1 of x is equal to what? 2n by x Jn of x, or also written as, it is 2n Jn of x is equal to x times Jn minus 1 of x plus x times Jn plus 1 of x. Okay, so it is expected that if you want to really answer such type of questions based on recurrence relation, so only option is, you should remember this recurrence relation. Use your tricks. I have already told you how to remember this formally. Okay, now let's have the next question. What is the next question? Bessel's function Jn of x is given by. So here the expression for Bessel's function is required. Okay, so as it is mentioned, option A is the correct one. You can find here there are slight changes in the remaining option. So it is what summation. First thing that you have to remember is the summation should start from what? It should start from 0 to infinity. So our variable of sum is what? It's nothing but r. So r takes the value from 0 to infinity. Then what we have? There should be minus 1 raised to power r. Yes, right. Then x by 2 raised to power what we have? N plus 2r, right? 2r must be there. And then r factorial and gamma of n plus r plus 1. So this is the correct expression. In the remaining expressions, you find certain terms missing or something is wrong, right? So option A is the correct one. Okay, let's have the next question. What is the next question? Next question is j minus n of x is equal to. So what is the value of j minus n of x, right? So this can be obtained only by making use of the expression for Bessel's function. So as we know that jn of x is given by what? It is given by summation r equal to 0 to infinity minus 1 factorial gamma of n plus expression I have already derived in the class, right? So once again, so how do we obtain this? So what I have to do, I have to just replace n by minus n. Okay, so I will replace n by minus n everywhere. So such type of changes will be there. Now what we find here, so here when we will put r is equal to what? 0, right? So here you will get a negative function inside the gamma, right? And we know that the gamma of negative function is always infinity, right? That is gamma of minus m is always infinity, not defined if m is greater than equal to 0. So here when I'll put r as 0 up to n minus 1, that is value less than n, right? If r will take the value less than n, then this term will be nothing but act as a negative term. Okay, so it will not be defined, right? So this is possible only for r less than n. Okay, so it means when r will take the value as equal to n, then this will get defined. Okay, so this is defined only from r equal to n to infinity. So note the change here. I have not committed a mistake. This is according to definition. This is defined right from r equal to n to infinity. Okay, now then what we do? So here I have to obtain the expression jn of x. So what we will do? We will put r is equal to n plus k. R की value n plus k substitute करो. So now lower limit is what? When r is n, right? So when r is n, what will be k? Obviously k will be 0. And when r tends to infinity, so what will be k? K will tends to infinity. So this becomes, so in terms of new variable, that is k, it will take the form k equal to 0 to infinity. Then r is n plus k. So this will become n plus k factorial. And the gamma function will become k plus 1. So like this we have. Now the variable of sum. What is the variable of sum? How do we decide that? So summation runs over k. Okay, summation runs over k. So that's why minus 1 raised to power n will be constant. So we'll take this outside and write down the remaining terms. Now, what is n plus k factorial? So as we know, what we know? We know that the uh, gamma of n plus 1. What is gamma of n plus 1? It is nothing but n factorial. So this n plus k can be written as what? N plus k factorial can be written as what? Gamma of n plus k plus 1 by using this result, right? So this is replaced by what? Gamma of n plus k plus 1. At the same time, what will be gamma of k plus 1 by making use of this? So gamma of k plus 1 would be written as k factorial. So if I compare this with the definition of the gamma function, so what we have? Yes, so what we have? We have here this as, so what is the definition of gamma function? It is Jn of x is equal to summation r equal to 0 to infinity minus 1 to the power r upon r factorial gamma of n plus r plus 1 into x by 2 raised to power n plus 2r. Now look at this term. Look at this term. There is only one change. What is that? The variable of sum r is now here replaced by k. So it's a dummy variable, right? If it follow the same pattern, right? Whatever is the requirement of this basis function, and if in place of r, if I write k, then also this is a basis function because of the dummy nature of variable of sum. Okay, so this is my what? This is nothing but this entire, this much term is nothing but what? This much is nothing but what? The basis function. So that is what? Jn of x. So in this way we have j minus n of x is equal to minus 1 raised to n jn of x. Hence the option A is given as the correct answer, right? So either you can remember this is a formula, very easy to remember what it is, j minus n of x, right? So just remove this minus sign, right? So we have j n of x, and this minus sign will be raised to the power n, right? So we have minus 1 raised to n. In this way one can remember it. Okay, now let's have the next question. But the next question, that is Jn of minus x. Now see here, you should not get confused. Earlier, just in the previous example, what we have proved? We have proved j minus n of x. Okay. In the earlier result, we have proved jn minus n of x. So what I am getting, j minus n of x is minus 1 raised to power n jn of x. Here what it is asked, jn of minus x. So what will be its value? So again in the same line we will prove it. So what we have? So jn of x, we will start with this, right? Let's put n is a positive integer. So replace x by minus x everywhere. Okay. So what we find? So here we can write this x by 2, right? Here we can write minus x by 2 as minus 1 raised to power n into minus into x by 2 raised to power 2r. Okay, so see here minus 1, you can, I'll write it here. Okay, so here minus x by 2 raised to power n plus 2r. This can be written like minus 1 raised to power n plus 2r, and then x by 2 raised to power n plus 2r. This way we can write. Okay, and now the value of this is given here. What is the value of minus 1 raised to power n plus 2r? The law of indices. This is minus 1 raised to n into minus 1 raised to power 2r. Now r takes the value 0, so 2r will be 0, and r takes the value 1, 2r will be 1, 2. So what is minus 1 to the power 2? Plus 1. And r takes the value 2, 2r will be 4. So this is an even power of minus 1. And even power of minus 1 is always plus 1. That's why this is simply what? Minus 1 raised to n into 1. Right? So this is what I have written, and which is taken outside the summation. Why? Because the variable of sum is r. Okay. Now what about the remaining term? Remaining term as it is. Okay. Now look at this. This is what? Same as the jn of x according to definition. See this one, right? Exactly same. So that's why what is jn of minus x? Jn of minus x is same as, again, the same formula. What is that? Minus 1 raised to n jn of x. So it's immaterial whether you are changing n by minus n or x by minus x. In both the cases, we have the same result, right? So even if by mistake, if you will choose this as an option, then also it is correct one. Okay. Let's have one more question, then we will stop. The value of j half of x is, so the Bessel's function for n equal to half is required. As we know that Bessel's function is a solution of Bessel's equation where n is a non-negative real number, right? Where n must be a non-negative real number. This is what is given. Okay. So here we will make use of again this formula of Bessel's function. As I want j half, right? So what we will do, we will put n is equal to half, right? we will put n is equal to half in this expression. So what we get and how this can be done. So just put n is equal to half in this formula, right? So put yes, just so put n is equal to half, right? So what we get? We get this as j half of x is equal to summation from r equal to 0, um, yeah, then minus 1 raised to power r upon r factorial, n is half, so half plus r plus 1 into x by 2 raised to power n is half plus 2r. Okay, now then just simplifying this, so I can take x raised to power half outside, right? Then 2 raised to power half also outside, because this is not containing r. So x by 2 raised to power 1 by 2 will be outside. According to the law of indices, what is left? 2r, right? So summation minus 1 raised to power r upon r factorial gamma of half plus 1 is nothing but what? It is 3 by 2 plus r into x by 2 raised to power 2r. Okay, and r takes the value from 0 to infinity. This is what we can simplify. Now what we do next, we will apply the sum. Applying the sum means putting r as 0, 1, 2, 3 like this. So what we get? So we get this as j half of x is equal to x by 2 raised to power half is there. Then when I put the sum, okay, so what we get, put the value r as 0, so we get minus 1 to the power 0, that is 1, r 0, so gamma of 3 by 2, and x by 2 raised to power 0, so that is 1. So what I am having? I am having the first term as 1 by root 3, 1 by gamma of 3 by 2. Similarly, when I put x as 1, so I will get x square upon, it is nothing but gamma of 5 by 2. Then plus next term will be x to the power 4 for r equal to 2. We get this as gamma of 7 by 2. Like this we get various terms. Now this is equal to, so I will write this as root x by 2, right? Raised to power half means root x by 2, and from this I will take gamma of 3 by 2 common, right? So what we have, 1 minus x square upon, what it would be? It would be 3 factorial. Then this will be 5 factorial and so on, right? So let's see how this comes out to be 3 factorial. Okay, so what we have, gamma of 5 by 2. So what is gamma of 5 by 2? That is according to the formula of gamma function. It is 3 by 2, 1 by 2, gamma of 1 by 2. Just decrease the numerator by 2. Go on decreasing till you get 1 and divide each term by 2. And once you get 1 by 2, multiplied by gamma of 1 by 2. Okay, so this is what I have as gamma of 5 by 2. Okay, now, so what I have done here, I have taken gamma of 3 by 2 outside, right? So what is the value of gamma of 3 by 2? That will be half gamma of 1 by 2. This is outside. So what is left? 3 upon, so that gives you 3 factorial. Okay. Now, then, so because of this. Now let's multiply and divide by x, right? Multiply and divide by x. So it is under root of x by 2. Then as we know, gamma of 3 by 2 is half times gamma of 1 by 2. So I will write it as half times gamma of 1 by 2 and multiply by x. So multiply by x, right, each term and divide by x. So what we have 1. So what we have x minus x cube by 3 factorial plus x to the power 5 by factorial like this. Okay. Now it's not looking good, but let's simplify. So root x will get cancelled. So you will have 2x root x in the denominator. Simplify the remaining term. So after simplification, you will get it as root 2 by pi x into, this is nothing but a sine series. So sine x. Okay. So in this way, this can be done. So I hope you must have understood. So this value j half of x can be considered as a formula also, right? So j half of x contains sin x. This term is common. If we will find out j minus half of x, there in place of sin